Alright, so just picking up with the practice test, this is continuing section 6.6, and it's similar again to problems that we've already done on section 6.4. So this one right here, we want to see if we can factor anything. We can't, with the 2, we can't, that is, multiply it into any powers. The other thing I'm going to do is taking the cube root of a negative. The cube root of negative 1 is negative 1. So I'm just going to pull out the negative right there to make it a little bit easier. And then how do we approach this? We want to get rid of all the cube roots. We want to get rid of cube roots in the denominator. So I need to be taking cube roots of things that are raised to something to the third power. So let's think about it. I have 2 to the first right here. How many more 2's do I need to be raising to the third power? I need 2 more 2's, because 2 to the first times 2 to the second would be 2 to the third. I have u to the fourth. I would like this number 4 to be a multiple of 3. And the closest multiple of 3 is 6. So what do I need to make u to the fourth into u to the sixth? I need another 2 u's. Because u to the fourth times u to the second would be u to the sixth. And then I have v squared. I would like that to be v cubed. I have 2 v's here, so I need 1 more. And then I need to do the same on the top as I did on the bottom, because now if I do the same on the top and the bottom, this whole thing is equal to 1. Anything divided by itself equals 1, and what happens if you multiply something by 1? Nothing happens. That's why we're able to do that. Okay, so that's what we're going to do. Let's simplify this out now. So we're going to have, we still have this negative here, so I'll just make that negative. The top really can't be simplified. We're going to have 3v times the cube root of, let's just make 2 squared into 4. And then we have u squared v. Okay, the bottom becomes the cube root of 2 to the first times 2 to the second is 2 to the third. U to the fourth times u to the second is u to the sixth. V to the second times v to the first is v to the third. Okay, and now we can simplify that. So taking the cube root of all these things cubed, the cube root of 2 cubed is 2. The cube root of u to the sixth is u to the second. I'm just dividing 6 by 3. And the cube root of v cubed is just v. We still have that negative 3v on top. And then the only thing that we can simplify here is we could cancel the v here and make that into a v squared. So it should be negative 3v squared times that cube root over 2u squared, and that's what we have. Actually, that is not what we have. Let's see what happened here. Where did we go wrong here? Oh, you know what? Here's the problem. I gotta be more careful with how I write this. This was not, I was treating this like a v cube. That's actually the cube root, so you gotta be careful with that. So this was negative 3v times the cube root. It looked like a v cube, so the v's actually completely cancel, and we're just left with negative 3. So that was not a v cube, that was the cube root. Alright, this one is done the same way, so let's start by, and actually we can make this a little bit easier right from the get-go. Because here's the thing, because these are both under cube roots, we can pull this entire thing under cube root and see if there's anything we can simplify right here. And actually, I'm just trying to see if we couldn't have done that on the other one because there's only one thing under the cube root. We can here. So 2 goes into itself once, it goes into 2, goes into 4 twice. N cubed, all 3 of those n's cancel, and 3 out of those 4 cancel, so we're left with 2n. So this is the same thing as the cube root of 1, which is just 1, over the cube root of 2n, and that makes it a lot easier problem. So 1 over the cube root of 2n, how do we simplify this now? We need to get rid of the cube roots on the bottom. So how do we do that? Well, I have 2 to the first here, so I need another 2. I have n to the first here, so I need another 2. And the same thing on the top. Okay, so this is now going to become 1 times this thing, would just be that thing. So the cube root of 2 squared is 4 over n squared. And this becomes the cube root of 2 to the first times 2 to the second is 2 to the third. You can skip this step too if you see the pattern. N to the fourth times n to the second is n to the third. If you don't see the pattern, I would recommend just doing it like we're doing. So the cube root of 4n squared over cube root of 2 cubed is 2, cube root of n cubed is n, and that's as simple as we can make it. So let's just double check, and that's the answer. Alright, we'll start 6-7 and we'll finish it in the next video. So 37 and 38, it says solve each equation. What you need to do with radical equations is you need to isolate the radical. So here's a radical, but it's not isolated right now. So the way that you isolate it is you move the 4 over. So you get square root v minus 1 equals Negative 2 plus 4 would be 2. Why did we isolate it? Because now we can do what we need to do to get rid of the radical. So the opposite of taking the square root is squaring. And whatever I do to one side, I need to do to the other. So squaring and square rooting cancel each other out. We're left with this. And 2 squared is 4. So we solve by adding 1. Okay, now this is the important thing. When you square something, you sometimes introduce what's called an extraneous solution. So we need to we need to double check this solution by plugging it in. That's what it means to check. Just plug it in. So let's plug in 5 right here. So you get the square root of 5 minus 1. What happens is you get these solutions that are kind of fake solutions. In the video on that section we'll talk more about it. Square root of 5 minus 4, or 5 minus 1 is 4. The square root of 4 is 2. 2 minus 4, that does equal, sorry, that's supposed to be negative 2. That does equal negative 2, so that checks out. So 5 is not an extraneous solution, it's a real solution. Alright, same thing here. This is a little bit different because now both sides have a square root, although that makes it a little bit easier for us. That means we can just directly square both sides. Whatever I do to one side of squaring it, I have to do to the other as well. So squaring and square rooting, those will cancel each other out. And we're left with this right here. Let's move all the b's to the same side by adding 2b. So we get 5b plus 16 is negative 9. Let's move the 16 over by subtracting it. So we get 5b equals negative 9 minus 16 is negative 25. We'll divide both sides by 5. And we wind up with b equaling negative 5. I'm going to put a question mark because we're not sure yet. We haven't checked to see if it's extraneous. So let's double check that. Let's plug in negative 5. So 36. Sorry, that's not a 36, that's a 3b. So 3 times negative 5 plus 16. Does that in fact equal square root negative 9 minus 2 times negative 5? Let's check. So this is negative 15 plus 16, which is 1. And this one is going to be negative 9 minus 2 minus 5, that's plus 10. So that equals the square root of 1. So the square root of 1 does equal itself. That means negative 5 did work as a solution that's not extraneous. Okay, in the next and final video we will finish this practice test with the other problems on 6.7.